Hello everyone, welcome back. So far we have learned a lot about insertion operations on linked list data structure. Today and in the subsequent videos we are going to talk about deletion operations on linked list data structure. Mainly this video is going to be about how to delete an item or a node from the beginning of the linked list. If you guys know how to insert a different location in a linked list data structure, I'm pretty sure deleting a node from the beginning of the linked list is going to be super easy for you guys. What we are going to do is basically we just want to update the head pointer and make the head pointer point to the next node, so this way we can get rid of the first node. So how we can do this and how we can make head node, instead of storing memory 600, and we will have it store memory 100, which is the memory location of the second node. Where we can get this memory address of the second node, we can get it from head.next, because head.next stores the memory address 100. So we can just simply set head equal to head.next. This way this connection is broken, and we are going to maintain this connection, which is head is going to point to next node or the second node, and this time head stores memory address 100. This is super easy operation, but there are two corner cases we need to take care of before deleting a node from the beginning of the linked list. First, we are going to check if the list is empty. If is empty, then we just want to return prompt the user and just want to return. We don't want to do anything. The second corner case is if we have maintained a tail pointer also pointing to the end of the linked list. If we have only one node in our linked list, say this is our linked list and we have only number 10 having memory address 600, this points initially to null. Both, in case of having one node, both the tail node and head node points to the same node. So head node points here, head pointer and tail pointer points here. Both tail and head stores memory address 600. This also stores memory address 600. So if we say head equal to head.next, so head.next is null, so head is going to become null, but we still have a pointer to this node. This node is not deleted. Tail pointer is still pointing to this node. In case of having one node in the linked list, we again going to check if after deletion, if our list becomes empty, if head equal to null, or we can call our function if is empty. In that case, then we update the tail pointer. Also will make tail equal to head or tail equal to null. Let's make it head. So this time after deleting this one node, both head is equal to null and tail becomes null. So our list becomes empty. Tail equal to null. These are the two corner cases to check before deleting an item from the linked list. After updating this pointer, making the head node point to the next node, so what's going to happen to this node? This node is not referenced by any pointer. We basically broke the reference to this node. So this node becomes, the initial node becomes eligible for garbage collection. The automatic garbage collector of high-level programming languages such as C#, Java, or Python will automatically clear up or delete this node and free up the memory. But in case of low-level languages like C# or C, we have to manually delete this node by calling the delete or free function. Before updating this connection or this pointer, we need to maintain a temp pointer to this node, so that using this temp pointer we can delete this node. Talking about C#, C# uses a managed memory model, which means the .NET runtime automatically handles memory management for you, including the collection, allocation and deallocation of the memory for objects. This is done basically by the garbage collector, or sometimes called GC, which is a part of the .NET runtime framework. When an object is no longer used or no longer referenced, in this case our head node, which it means there is no reference to this and it becomes eligible for garbage collection. So the garbage collector will periodically run and clear these objects which are not referenced by any pointer, so we don't have to worry about memory management like C or C++. I'm assuming we have not referenced this pointer anywhere else in our memory. If any node is not referenced by any pointer throughout our program, it becomes eligible for garbage collector, and the garbage collector automatically runs periodically and check for any node or memory location which are not referenced. They will be freed and deleted. So this way we can delete an item from the beginning of the linked list. Let's jump to the IDE and write code for that. So I'm gonna define a function here. So let's have this function return int. After we delete the item, we just want to return the data of that item. So let's call it delete from beginning. It doesn't take any parameters. So before deleting the head node, we want to maintain the data part of the head node so that we can return it from this function. Let's define variable int data equal to head dot data. But before doing that, let's check if our list is empty. If is empty, we just wanna prompt the user list is empty, and we just want to return say -1, or I could. Otherwise, we maintain the data part of the head node. Then we just want to return the data. To delete the head node, we just say head equal to head.next by updating this pointer. After deleting, we again gonna check if head equal to null or if is empty. Then we will just say till this dot till equal to head or equal to null. So let's check this function. Say I have 10, 20 up to 90. So I want to delete the head of the nodes, in this case, which is 10. I say list dot delete from beginning. Ten is gone. We have 20, 30, 40. Say we have only one node in the linked list. So the list should become empty. Yeah, the list is empty and we don't have any item. If we don't have any item in the list, this should print list is empty, and this is from the print function. Thank you guys for watching, and see you in the next video. Bye bye.